All right, so this is Chapter 6, Section 3, Binomial Radical Expressions. Our learning objective is to add and subtract radical expressions. A couple pieces of information. The phrase like radicals are radical expressions that have the same index and radicand. So they have the same little number. That's the index. And then they have the same number underneath the root sign, which is the radicand. So when you're combining radical expressions, sums and differences, so sums means with addition and differences means with subtraction. So when I'm adding two values that have a root with the same index and radicand, I can go ahead and add the coefficients from the front and combine them together to make one of its own coefficient multiplied by that root with the radicand. Same thing with the minus. If I have the same root and radicand, the same index and radicand underneath the root, I can go ahead and subtract the values out front and write that multiplied by my root. So let's take a look at these example problems. 7 cubed root 5 minus 4 square root 5. So this cannot be combined. I do not have the same indexes. This is a cubed root and this is a square root. So I cannot combine those two. But if I look at B, 3x root x times the square root of xy plus 4x times the square root of xy, I can use this property. So it says I can take the 3x plus the 4x and add them together times our root. So 3x plus 4x is 7x, square root xy. And then let's look at this one. This is the difference one. It matches this guy. So in this scenario, A is 17 and B is 15. 17 minus 15 is 2. And I have still this 3x squared underneath the fifth root. All right, moving on. All right, so let's take a look at this sum here. We've got cubed root of 250 plus a cubed root of 54 minus the cubed root of 16. I have the same index. All of these indexes are 3, but I don't have the same radicand. So what I'm going to do is I'm going to simplify these down a little bit more. We made a chart. Let me show you where that chart went. If you look at this chart and I go to the cubed column, there's some special numbers that we're going to look for out of our cubed column. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. If I fast forward to today, I can go 250. I'm going to cut each of these in half because they're all even. So the first thing you do when you're trying to factor something is you cut it in half. So I know that 2 times 125 is 250. This happens to be a perfect cube. Yay! So then I write this as cubed root of 2 times 125. And we know the cubed root of 25 is 5, so I'm going to go ahead and bring that out. And poor 2, he's got to stay inside because he is not a perfect cube. All right, so next item up for bid. Just getting those prices right. shout out. We have cubed root of 54. So I'm going to, again, cut it in half because that 54 is even, so I know he has a 2 as a factor. What times what is 54? So I'm going to cut 54 in half. That is 27. And aha, I know that 27 is a perfect cube. So this is the same as 2 times 27 underneath the cubed root. And I'm going to go ahead and take the cubed root of 27 to get 3. And because the 2 is not perfect, he stays inside. Okay, last but not least, I'm going to cut 16 in half and get 2 times 8. 8 is a perfect cube. So 16 is 2 times 8. I'm going to go ahead and take the cubed root of 8 and get 3. And now I have the 2, since he's not a perfect cube, stays underneath the radical sign. All right, so now I have the same index of 3 and the same radicand of 2. So then I can add, although one of these is a minus. So this one is a minus. Boop. Okay, so I'm going to and how about we write the correct number here? Cubed root of 8 is 2. There we go. Now we're talking. So we've got, I can write this as 5 plus 3 minus 2 times cubed root of 2. And 5 plus 3 is 8. 8 minus 2 is 6. So this is 6. Cubed root of 2. Booyah. Answer. Okay, so let's go ahead and let's switch from adding and subtracting to the product, which is multiplying. So we're going to go ahead and multiply these out. We're actually just going to straight up FOIL this out like we've been doing since 7th grade. 3 times 2 is 6. 3 times 4 root 5 is 12 root 5. 2 root 5 times 2 is 4 root 5. And 2 root 5 times 4 root 5 is 2 times 4 times square root of 5 times square root of 5. I'm going to leave that out there because I'll show you how to simplify this down. So here we got 6. 12 root 5 plus 4 root 5 is 16 root 5s. And then I got 2 times 4. And then anything, this is equal to square root of 5 times square root of 5 is like the square root of 5 times 5. And the square root of 25 is 5. So anytime you have a square root times itself, you're going to go ahead and get out what is underneath that square root. So then this becomes 6 plus 16 root 5 plus 40. 8 times 5 is 40. And then you add 6 plus 40, and you get 46 plus 16 root 5. Yay! All right. Let's take that idea and apply it to conjugates. So conjugates are expressions like root A plus root B and root A minus root B that differ in only the signs of the second term. So if you look here, this is minus, here it's plus. When A and B are rational numbers, the product of 2 radical conjugates is a rational number. So let me show you what that means. So if I were to FOIL these 2 conjugates, 6 times 6 would be 36. 6 times root 12 is 6 root 12. All right, so 6. Negative 12 times 6 is negative 6 root 12. And negative root 12 times negative root 12 is negative 12. Because root 12 times root 12 is equal to 12. And in this case, I have a minus. All right, 6 root 12 minus 6 root 12 is 0. And I just have 36 minus 12, which is 24. So what happened was I got a rational number. The square roots, because one's positive and one's negative, they cancel each other out. All right, let's see that one more time with this 3 plus root 8 and 3 minus root 8. 3 times 3 is 9. 3 times negative root 8 is negative 3 root 8. Then we have its opposite, same buddy. And then square root of 8 times square root of 8 is 8. And because it's plus and a minus, it's minus 8. These two give us 0. And 9 minus 8 is 1. And then once again, I get a rational number. So anytime you multiply a number by its conjugate, you get a rational number. So how does that, where are we going to use that? Oh, that's right. We're going to use it to rationalize the denominator. So we're going to take the conjugate of the bottom, which is the same thing, just opposite sign in the middle, and I'm going to apply it here as well. So essentially I'm going to be multiplying the denominator by its conjugate and the numerator by the conjugate as well. So when I multiply 2 root 7 times root 3 plus root 5, I'm going to get 2 times root 7 times 3 plus 2 times root 7 times 5. Here, I have to FOIL out a little bit smarter. Root 3 times root 3 is 3. Root 3 times root 5 is positive root 15. Negative 5 times root 3 is negative root 15. And negative root 5 times root 5 is negative 5. So now let's make this sing. Negative root 15 plus root 15 is 0. 3 plus negative 5 is negative 2. And I get 2 root 21 plus 2 root 35. Awesome. So I'm going to go ahead and give each of these terms its denominator of negative root 2. So I get 2 root 21 over negative 2 plus 2 root 35 over negative 2. That way I know 2 goes into 2. So this is negative root 21. 2's cancel and give us negative 1. Plus 2's cancel and we get negative root 35. Go ahead and just write it as minus root 35. So the answer is negative root 21 minus root 35. All right, let's see that one more time. Last example. If we are going to multiply the top and the bottom by the conjugate, that's the positive version of this, so it's 4x times 3 minus root 6, and then plus, it's conjugate, 3 minus root 6 times 3 plus root 6. So essentially, 3 plus root 6 over 3 plus root 6 is 1, and it's like I just have multiplied by 1. Let's go ahead and distribute this out. 4x times 3 is 12x, and 4x times root 6 is 4x root 6. 3 times 3 is 9. 3 times root 6 is 3 root 6. Negative 6 times 3 is negative 3 root 6. And negative root 6 times root 6 is negative 6. Okay, so we got 12x plus 4x root 6, and these cancel each other out, and I got 9 minus 6, which is 3. I'm going to go ahead and divvy up the 3 to each of these denominators. I get 12x over 3 plus 4x over 3 root 6. And that gives us 12 divided by 3 is 4. And then plus 4x over 3 root 6. And that is as simple as we can get. Go ahead and take a moment, summarize what we did. Make sure you guys include the learning objective, which is to add and subtract radical expressions. Include that the index and the radicand have to be the same. Include simplifying the radicand. Include how to multiply. When you multiply, it's like foiling, like we did with binomials. Include a little piece on conjugates and explain how we use conjugates to rationalize the denominator. And that's all for today.